Hello everyone. Welcome to this talk on building cost-effective asynchronous GraphQL APIs using serverless. It's an event-driven architecture. So we will explore here how to decouple heavy workloads, improve responsiveness, and also reduce infrastructure costs while building a scalable and cost-effective digital platforms. I'm myself Balaji, a senior engineer. I specialize in cloud computing and research more on serverless event-driven architectures. So here, let's see a traditional architecture on how a system works, where consider a website which has car details, which sells cars, and then it has all the car details like Carvana maybe. Um, there you get all the details of the cars and everything, Carfax reports. So these are like different kinds of data being fetched from different APIs. Many could be real time. So to get all the details from different APIs, maybe 15 or 20 different APIs, and then to combine everything and then to provide a result, it really takes a lot of time. So when you have a monolithic architecture or even microservices, this definitely reduces the amount of it definitely increases the amount of time it takes, so the latency is pretty high, and also the amount of the cost that needs to be spent on these servers will be really high. So let's look at the ways to avoid this and then have an better architecture. So to analyze more on the traditional backends and how how they struggle, the first problem is, like as I said before, it's the slow operations block, where there is complex searches for large inventories, and then also there could be traffic spikes where during the morning, and then when there is an deal or something, that could be really high traffic, and then that could result in poor performance and also poor user experience, since it slows down the listing of the cars in this case. So let's look further. Right now, consider this as a website which publishes all the car details of a specific car, and then the user can make a decision based on that whether to buy the car or not. So it's really important to load the website right away and to be really responsive. So here you have the key details of the car, the vehicle details, and the price details, the owner's reviews about the car, and also inspection, which is like a report on the car, and also it could include the Carfax reports, the build of the car, and all those different details. So these should be fetched from different APIs and to combine them and then provide at one specific page. It's a really time consuming process. Let's also look at how we have evolved from the past 10 to 15 years on building APIs. So initially we had the monolithic architectures where we build large APIs, which is part of single code base, and then that handles everything, and they are put on large on-prem servers. And then we move towards service-oriented architecture, where some part of the APIs are split, which are much more universal for that specific company, and those are used, and then something specific to the business logic of that specific product is made part of it as a separate service. And then we then move towards microservices, where that specific service is again split into further smaller services. And now we are in a case where it's shared services where it's a microservices architecture, but it's like again like SOA where we split um, the services and then which are much more common or used along with the microservices, and then this will result in much more um, reuse of the code and also increases the standardization. So here we are looking at how we move from microservices to shared services, where we make the logging, authentication, listening to an event, different event brokers. So all these things can be common to different services. So this could be shared within the services. And now, as you see the world, it's asynchronous. It's not synchronous, where the systems evolve, and then you should be able to adapt accordingly rather than rewriting everything. And event driven architecture is a place that could happen easily. I could explain more with the in the next couple of slides on this. So as I said, we could move towards standardization of the services using shared services, and then definitely it's faster in deployment and also development when we move towards event driven architecture and serverless. And also since we share services, it's easy to observe, increase the observability and also governance. And also there is easier onboarding, where you could, since the services are have more common substance, so onboarding will be much more easier. So this is an example of how the asynchronous system works in the real world. So consider you need to drop your iPhone for a repair. You go there, make an appointment, and then give it to them. um, Mostly you don't wait, you wait for a call back or an app notification that it is done, and during the time then you move on and then do your next thing, maybe order a food. And over there mostly you don't wait. As the food gets ready, you look at other stuff, like if you need to give it for a dry cleaning, then you go there and then give it. And once you give it there, maybe the iPhone is ready, you come back and then collect it. And the food is ready, then you collect that. And then the dry cleaning is ready, you collect that too. So here you don't really wait on a specific process. So this is how the world works, and that is how the system also should work, and not synchronous, where you have threads and then you have spawned multiple threads and then you wait for each process to complete. That is how the systems were before, and then moving towards asynchronous systems with event driven architecture have greatly helped in reducing the cost, improving latency, and a better responsive system. So here we're looking at how we could decouple the heavy monolithic or even heavy microservices to move towards a faster user experience. So we use serverless, which has, since we use the AWS, we are in the AWS cloud. We have AWS Lambda, API gateways, and here we also use OpenSearch and DynamoDB. So event-driven architecture has event-driven computing, where the Lambda can listen to SQS and then fetch all the events that comes through and then update the data accordingly. And also GraphQL helps here, where we need to fetch the data that we really need. There could be 500 different types of elements as part of the API, and we don't need really all of those. So GraphQL really helps here to fetch the details that we really need. And then asynchronous pattern, since as I mentioned before, SQS helps to fetch the data as the events comes through, as the different APIs that we call gets updated, and then we get the events from those APIs, So this makes the get the real-time data without making the user to really wait. So all these background processes gets completed as the real world example that I mentioned, where the process gets completed on its own and all we need to do is like get the data when it's really available. So in this case, that's how it works. So the real-time aggregation via asynchronous workers helps here. So looking at the overall architecture from monolithic and also heavy microservices based without shared services, this is how we move towards. So when we request a car's details, it comes to the API gateway, and then the Lambda looks at the details of the specific VIN or car, and then if it is available in open search or the DynamoDB, then it fetches the details. If not, if the details are not available, then it goes to make a call to the real-time APIs, which could be slower. So that is like an not the default option, but if the details are not available, something is wrong with any of the APIs, then we use that. In most of the cases, 99.99%, it goes to the open search or the DynamoDB and then fetch all the details that are required. So when you look at how OpenSearch or the DynamoDB gets updated here, it comes from Lambda, which processes the details from the SQS events, and these SQS events are from different APIs, real-time APIs, which provides the events as they get updated. So we get the latest events, and then which result in getting the latest data to be part of the OpenSearch or the DynamoDB all the time. So to just differentiate why we use OpenSearch and DynamoDB, OpenSearch is expensive, DynamoDB is not, but it's up to the user on what they search based on. If it is a specific primary key like a VIN, then DynamoDB makes sense, but sometimes they don't, where it's a car and then all they look for is like, give me all the Toyota or give me all the Hondas, then OpenSearch totally makes sense, where you filter by make and then you get all those data to the user. So here's a blueprint of how we move towards how the data flows from the API gateway to the GraphQL, which is a Lambda, and then we have specialized workers, which does the heavy lifting asynchronously. So use the car buyer, which is a web or a mobile app, and then use serverless infrastructure as code to build all these. And then from the API gateway, you call the GraphQL endpoint, which is a Lambda, and then the GraphQL endpoint that handles authentication and also has the context. And then it goes to the resolver. The resolver identifies the data that is needed and then makes it understandable to get the right data from the DynamoDB or OpenSearch. And once that is done, then we provide the response back. So here the SQS, as I said before, listens to the events and then updates the DynamoDB or OpenSearch on the backend. This is an example for a resolver of GraphQL. So when there is a search for the current inventory of make, model, price, or whatever the search criteria that the user wants to select, they can select, and then we can get all those data from the OpenSearch. So the GraphQL resolver helps here a lot to get that done. And here the resolver, how it instantly works to get the data from the DynamoDB. Here is an example of SQS event listener, where as the events comes through the SQS, we listen to it and then update the DynamoDB accordingly. So here is an example of how we get the car details by VIN. we get the status. If it is like a payment related data that we now are going to fetch, then we will be able to get all these details accordingly. Here, overall, we looked at how to build an asynchronous event-driven architecture, which helps to avoid high cost, and also improve the performance. So this really helped us to reduce the cost by almost 70%. We had a Scala based monolithic architecture, and then from there we moved towards a microservices, but still Scala, which is not much event driven. As Scala, we had more threads, and then high CPU intensive EC2 instances. Moving towards Lambda, totally avoided all those costs where they really run at night, which doesn't make sense. So on cost based metrics, moving towards asynchronous event-driven architecture totally makes sense, but not just that. It also makes sense on having a much more responsive UI, where you get the latest data all the time. So I would like to end it here. Thanks for listening.